Good day everyone. Today we're going to see end of chapter 1 and chapter 2 in measurement device. Myself Thinega daughter of Vasan and I'm from DTK1A and my metric number is 10DTK21F1065. First question is define the terminologies for scale and range. A system of order marked at fixed interval used as a reference standard in measurement. The extent to which or the limits between which variation is possible. The range of steel price, a wide range of styles. B. Explain briefly gross error, systematic error, and random error in measurement. Gross error. The gross error mainly occur due to carelessness or lack of experience of human being. These cover human mistakes in reading recordings and calculating results. These errors also occur due to incorrect adjustment of instrument. Systematic error. The systematic error are mainly resulting due to shortcomings of the instrument and the characteristic of the material used in the instrument, such as defective parts, aging effect, environmental effects, etc. There are three types of systematic error. First of all, instrumental error, shortcoming of instrumental, for example, friction in the bearings of various moving parts. Misuse of instrument, example, poor initial adjustment, improper setting, and etc. Loading effect due to improper way of using the instrument. Secondly, environmental errors due to condition external to the measuring instrument. Example, temperature changes, pressure changes, thermal EMF, cross capacitance, aging of equipment, and etc. Third is observational errors. There are the errors introduced by the observer. These are many sources of observational errors such as parallax error while reading a meter, wrong scale selection, the habits of individual observers, and etc. Random errors. Some errors still result tough the systematic and instrumental errors are reduced or at least accounted for. The cause of such errors are unknown and hence the errors are called random errors. These errors cannot be determined in the ordinary process of taking the measurements. The given value for each resistor connected in series are R1 equals to 6.5 kilo ohm, R2 equals to 450 ohm, R3 equals to 12 kilo ohm. All the resistors connected to supply voltage equals to 15 voltage. Total measure value of resistance is 20.5 kilo ohm. Draw suitable schematic diagram and calculate the total resistance, absolute error, percentage of error, and percentage of relative accuracy. The total resistance is 18950 ohm. Measured value is 7.6% and the accuracy value is 92.43%. These are the schematic diagram. Second question is explain loading effect in DC voltmeter using suitable diagram. These are the diagram and ideally a perfect meter would have no loading, but all meters have some loading effect on the circuit they are measuring. When voltmeter connected to circuit, it will have lower the effective resistance of the circuit and change the voltage reading. Total resistance will decrease, go the voltage across component will also decrease, which is called voltmeter loading. This is the sketch of DC voltmeter with range from 0 to 10 voltage, 0 to 50 voltage, and 0 to 100 voltage. The procedures are switch on the multimeter, turn the dial to DC voltage, using the knob on the dial select the most suitable voltage range. Do not overloading the meter because it may damage the meter. If the voltage is unknown, set a meter at maximum range. Insert the negative probe of black probe. Insert the positive probe. Make sure they connect to right circuit. Next, place the negative lead by voltage point. Place the positive lead to high voltage point and at last, note the reading from side to side. First question in EUC2 is, what is the function of the signal generator? A signal is one of the most essential pieces of technology in electronics and communication. It's used to produce different types of signal and frequencies for a variety of purposes such as testing, troubleshooting, and designing. B. State three differences between an oscilloscope and signal generator. An oscilloscope reads voltage in a circuit, whereas a signal generator generates voltage. Oscilloscope is a measuring instrument, whereas a signal generator does not measure any parameter. An oscilloscope presents a picture of a waveform or signal on horizontal and vertical axes, whereas a signal generator's function states its name. Explain the procedure to calibrate an oscilloscope. Switch on the oscilloscope. Put the probe to the input. Touch the hook tip, which is probe, to the coil and crocodile tip to the ground. Selection mode must be same with the input and also voltage per div same with a value at curve. Select time per div, then choose 0.5 ms. It will get f equals to 1 kHz. Lastly, on the screen, the waveform appears in square wave. Question D is, what is the purpose of doing the calibration process of the oscilloscope, which is to obtain a more accurate value and graph. This is the figure 1 and it shows a waveform. These are the answers for question E Roman 1, Roman 2, Roman 3 and 4. Question 2 is, state the usage of Whetstone bridge. The Whetstone bridge is used for measuring the low resistance value precisely. Whetstone bridge along with operational amplifier is used to measure the physical parameters like temperature, strain and light. Name R3 and state its function in the circuit. R3 is called standard arm. In Whetstone bridge circuit, R1, R2 and R3 are resistors of known resistance and the resistance of R3 is adjustable. Describe the operation of the Whetstone bridge. When balanced, the Whetstone bridge can be analyzed simply as two series strings in parallel. In our tutorial about resistor in series, we saw that each resistor within the series chain produces an IR drop or voltage drop itself as a consequence of the current flowing through it as defined by Ohm's law. Third, prove that R1 R4 equals to R2 R3 is the balance condition null reading for Whetstone bridge. No current flow to galvanometer. Ig equals to 0A and the current flow through R2 is equal to the current flow through R4. 4. If the value of each component is R1 equals to 4.0 times 103 ohm, R2 equals to 6.00 times 103 ohm and R3 equals to 15.00 ohm, calculate the resistance of R4. R4 equals to R2 times R3 slash R1 equals to 600 times 15 slash 400 equals to 22.5. Third question is, draw AC clamp meter block diagram and this is the AC clamp meter. B. Explain the principle of clamp meter. Clamp meters consist of transformer jaw, Hall element and cap. Hall elements are used as a sensor to detect DC current and placed across a cap created by cutting off part of the transformer jaws. When they occur, a flow of magnetic flux proportional to both AC and DC primary currents in the transformer jaws. These Hall elements detect the magnetic flux and takes it out as an output voltage. Question C is, as a professional technician who practices good values, shows the connection and briefly lists the procedure of using clamp meter in the following situation. Making preparation before start using clock meter, measuring AC current, AC voltage R4, R3. Before taking DC current measurements, wait for the display to stabilize, then push the zero button to ensure correct readings. Zeroing the meter removes DC offset from the reading. The zero function works only when the dial is set in the DC current measurement position. It is shown in the figure below. Last but not the least, select the AC current function using the dial. The display should show a jaw sign which confirms the measurement is being detected. Open the jaw-like structure by pressing the side lever and insert the conductor through which the current is to be measured. Then, release the side lever, the conductor between the alignment marks inscribed on the jaws. The display will show the appropriate readings.